Hello. So in the last video, we have discussed about how to write a bug bounty hunting report and how to submit in the HackerOne and also by mail, right? So today we are going to discuss about cross-site scripting. So this is the lab for cross-site scripting in the ports figure. You can check this thing. We will do practical session in this, and also we will explain bug bounty reports, real bug bounty reports based on cross-site scripting. Okay. So, what is cross-site scripting? It's a type of security vulnerability typically found in the web application. It occurs when an attacker injects a malicious script into the web pages viewed by the other users. These scripts can execute in the victim's browsers, allowing the attacker to steal sensitive information or impersonate users or manipulate the display card. So, cross-site scripting vulnerabilities usually occur in the input field, such as search bar, comment section, or contact form, where user can input data that is later displayed on the web page. Or the attacker can exploit this vulnerability by injecting malicious script, typically written in JavaScript, into this input field. When a user visits the affected web page and interact with the compromised input field, the injected script got executed in the browser. So the attacker can steal the session cookies, redirect the users to malicious website, and deface the web page or perform actions on the behalf of the victim. So, for example, if there is any search bar, if there is any vulnerable search bar, the website displays the search result without proper input validation, making it susceptible to the cross-site scripting attack. An attacker can inject the malicious script to that search bar. When a user submits a search query, the malicious script gets executed in their browser, displaying an alert message. Let me show an example for that. So for that, we have to access this access lab. Yeah, open this. Okay, I'm sorry. Access the lab. Oh shit. Actually, I forgot my password. Forgot your password. Let me reset it. I'll do one thing. I'll pause this video 1 second. Okay, fine. Log in. Okay, I resetted my password. I forgot those. Yeah, sure. Okay, access the lab here again. Okay. Yeah, here. Let's say this is a vulnerable website with a vulnerable search bar. Okay, so this website display, let me type anything. Hello. So the website display the search result without proper input validation, and we can use any symbols. It's also got displayed here. Okay, so yeah, so it's not avoiding any suspectable symbols or any numbers. Okay, so when a user submit a search query, the malicious script get executed in their browser, displaying an alert message. So in to solve this lab, we have to display an alert function. So we can type script here. We can choose this script alert one script and click search. Yeah, we got an alert message. In a real attack scenario, the script could steal the user's session cookies, allowing the attacker to hijack their session and perform the unauthorized actions. And let me show the reflected XSS also, not stored XSS also. This is a reflected XSS. I'll give an example for stored XSS also. Okay, so access the lab. This is a today's task. You have to complete all these cross-site scripting lab in the Portswick. Okay, back to all topics. You have to complete these things. Cross-site scripting lab. Yeah, they added more labs. Totally, they have 30 labs now. So here's the stored access things. So we can store. Let me open this view post. Yes, we can leave a command here. Okay, so let me add the script here. Script alert one script. Okay, let me add this in the name, and we can give an email address. We can give a website. Post comment. So thank you for comment. The comment has been submitted. We can go back to the blog. So the script got stored in the comment section. So whenever person visit that post, they got the script got executed, right? Fine. So, to prevent this cross-site scripting attack, the developers should implement proper input validation or sanitize the user inputs and encode output data before displaying it to the web pages. Additionally, using security mechanisms such as CSP content security policies will help to mitigate the risk of the cross-site script vulnerability. I'll show you some examples in the real world examples from HackerOne also. Yeah, reflected access via file upload. So here they wrote a summary, reflected access in this link via file upload, and they wrote the impact of this, and after that they wrote the step to reproduce. So go to this link, select any type of report, type your email in the email field, and type any other text in the other field. The upload function upload SVG or XML file. So we can build a chain of vulnerability. File upload vulnerability leads to cross-site scripting, or it can lead to account takeover. We can inject malicious script through XML or SVG files also, or we can also inject through PDF. Okay, so I think there will be a video of those. Yeah, let me download this and play it for you. Mhm. What happened? Okay, video download. Yes, it got downloaded. Okay, just wait and see. So they go to the contact us form. What do you need assistance with? I need help with my account. Type your email address, password problems, username. So in the attachment section, they are attaching the SVG files and also the XML file. So click submit. So they go back to the mail. Yeah, they got a pop up. Okay, but in this case, it will not, it's not a valid thing because just see here, the URL is not reddit.com. When they click those things, it will automatically got downloaded in our system and it executing in our system itself. So this thing is not a valid one. Okay, so I think They responded it's the same. Based on the initial description, that does not appear to be a security implication as the direct result of this behavior. The file will fire because it's expected. You're opening it from your local computer. Okay. So you have to make sure that the pop-up message or the JavaScript got executed in the correct domain itself. Fine. Okay. Then the next X is reflected on the redirect via URL path. Here, this is the link. When we click this link, it will automatically got a pop-up message. Okay, let me download this image and show it to you. Oops. I'll give an live example in LinkedIn. I hope it's not still it's uh, yeah, here we got the reddit.com site. So it is the reflected XSS. Okay. So yeah, they rewarded with some bounties also. Okay. And this thing, yeah, they used this payload and it worked. I think they have POC videos also. Let me check. No, they don't have any POC video. Okay, this is a number. Just type the number in the hacker one. You can get this result. Okay, so I'll do one thing. I'll show you another example of PDF injection. And second, okay, this is my demo page to do bug bounty hunting. Okay, wait. Yeah, I uploaded a vulnerable PDF here. Let me check. I don't know whether it's still vulnerable. Let me check that. So when we press accessibility mode, okay, press escape. Yeah, you got a pop-up. Did you see that? Let me try again. So it's the full screen mode and click accessibility mode. Then click escape. It's working, but one second, let me check another PDF. Yeah, this is the another PDF. So expand this, click accessibility mode, scanning for virus. Yeah, you got a cross-site scripting. But it you can see this is the vulnerability in the Edge PDF viewer, not in the LinkedIn. Okay. So I'll show another same thing in the Google or Gmail itself. Okay, one second. First of all, I have to download this thing. Download it. Yeah, I'll share this thing in the media edge PDF. Okay, I'll share this PDF in the Discord also. Okay, vulnerable PDF. Okay, let me open Gmail. Gmail. Let me open Classroom. Classroom Google. Okay, sign into Classroom. Continue. Okay, let me create a class. Test. Create. Got it. And classwork. Here we have the drive. Create. And second. Multiple grades. Okay, this is a drive for classroom. Fine. I'll upload in this thing. File upload, desktop, vulnerable PDF. So open this, click the three dot and open in a new window. So the URL is drive.google.com. Okay. Yeah, I think they fixed this thing. Okay, fine. No issues. Where is Gmail? Classwork, assignment, upload, browse, vulnerable PDF, test. Okay, the PDF got uploaded. Assign. Okay, open this. Click this. Open in a new window. Yeah, they fixed this thing. Oops. No, just let me try in the mail also. Actually, when we click this thing and open a new window, the pop-up got uploaded there. The JavaScript got executed there. Maybe they fixed those things. Okay, wait for a few seconds. I think my network issues. Okay. I hope you can hear my voice. Yesterday, I don't know how my voice is not got it. Okay, okay, fine. I'm attaching the PDF here. Test. Send items. Okay, open this. Open in a new window. Yes. Here we are also getting this pop-up and okay, the URL is googleusercontent.com. Okay, so Microsoft Edge vulnerability leads to the cross-site scripting in the Google. But this is not that much valid. It's just a P4 because when we refresh this, we got a message XSS 1, right? We didn't get any cookies or we didn't get any document or domain address. So it's not that much effective or it didn't give any impact. So when we try to find cross-site scripting, you have to level it up to P11. Okay, because P1 is the highest one. You have to improve your impact on the domain. You have to find cookie first in the cross-site scripting. Okay, so that's all for this session. Thank you.